Hi and welcome everyone to this lesson. In this lesson, we will discuss a phenomena that occurs in PV cells, which is called the shading effect. And we are going to discuss an important type of panels called the half-cut cells. And you will understand what is the relation between shading and using the half-cut cells panels. So what is the shading effect in PV systems? So if you look here at this image, you will find that we have here our panels. However, due to the presence of a chimney or a building or a tree, you will find that there is a shadow which appears on the solar panels. This shadow will lead to what? Lead to the reduction in the electrical power generated. Okay. So when a shadow is cast on a panel, whether by a tree or on any other building or a chimney, for example, it will decrease the amount of the electricity produced by the panel. Now, shading of just one cell in a module, just one cell like this, okay, which typically consisting of around 60 cells, can reduce the power output from the panel as much as 33%. So you can see that this shading effect is really harmful for our PV system. So how can we solve this problem? Okay, so we'll find something which is really interesting. So we'll find that we use something which is called the bypass diodes. The bypass diodes. The bypass diodes are used to solve the problem of the shading effect. So as you can see, this is a normal operation, okay? When we have sunlight falling on our PV cells or PV panels, as you can see here, okay? So the current is flowing through all of these panels normally, or cells normally. Now, when we have a shading effect, like here we have a shadow on this cell or this PV panel, you will find that what will happen if we allow the current to pass through this cell. You'll find that since all of these cells are in series, you'll find that the total current flowing through these panels is very low, very much reduced. Okay. So in this case, how can I solve a problem like this? In this case, we use the bypass diodes. The bypass diodes, what does it do? It bypasses a cell or a panel. So as you can see, the current will flow like this through these cells, which does not have any shading effect. Then when it comes to this cell or the panel which have shadow on it, what will happen in this case? The current will flow through the diode or the bypass diode. Okay, so it will form a short circuit on the panel, okay, as if this panel does not exist. So the current will still be high. Okay, so by using the bypass diodes, we will be able to cancel any cell or any panel which have a shading effect. So if you look at this image here, you will find that we have three types: unshaded cell, partially shaded cell, and completely shaded cell. You can see this unshaded cell which have all of the current, all of the solar energy, and it does not have any shading effect. So we will have 100% of the current and voltage coming out from this cell. Now the partially shaded cell, the output current is directly proportional to the illuminated area of the cell. No voltage change. So the problem is in our current. You can see that the current is reduced due to the presence of shading on this cell. Now for a completely shaded cell, we will not have any output, zero current, zero voltage. Okay. So let's compare the in case if we have a bypass diode or if we don't have a bypass diode. Okay, so as you can see here, we have 1, 2, 3, 4 panels. Okay, we have 4 panels here, or not 4 panels. We have how many panels? 10 panels. Okay, 10 panels. So we have here 10 panels. Okay, 10 panels. One of these panels, we have one panel which has a shading effect. Okay, which one? This panel. Okay, you can see there is a shadow here, which means it has a shading effect. Okay, so since this one has a shading effect, we have here a bypass diode. So this bypass diode will make a short circuit on the panel, so as if this panel does not exist. So each panel here has a voltage of 32.5 volt and the current 8 ampere. Okay, when we cancelled this one, so what is the output power? Power number 1 is equal to how many panels? We originally had 10 panels and we cancelled one panel. So we have 9 panels multiplied by the voltage of each panel, which is 32.5 volt, which will not change, multiplied by the current. Now, since we cancelled this panel, we will still have large current, which is 8 ampere, okay? As an example. So we will have a total power of 2340 watt, okay? Now, in the second case here, when the bypass diode does not work, okay? When the pass by diode does not work. So the power number 2, this panel which have shadow will still be connected. Okay, we will assume that the bypass diode does not exist. So in this case, we will have 10 panels. Total number of panels is 10 because we didn't cancel this one. Multiplied by 10 multiplied by what? Multiplied by the voltage, 32.5 volt, multiplied by the current. So the current here in this case, since we have one which have a shading effect in series with all of this, so the current will be reduced so much, okay? It will be, for example, 1 ampere. So we'll find that the output power in this case is 3 to 5 watt. So you can see that when we don't have a bypass diode, the total power coming from the panels will be reduced compared to the presence of bypass diode. Now, why is this? Because the panel which has a shading effect leads to reduction inside our current. Okay. So by using a bypass diode, we cancel the shaded panel. We now have 9 panels instead of 10 panels, but with a higher operating current of 8 ampere. In case of keeping the shaded panel, the number of panels would be higher, or 10 panels, but the current will be reduced a lot to 1 ampere due to shading effect. So that the total power will be reduced compared to the bypass diode case. So the first solution for the shading effect is that by using the bypass diodes to cancel the panel which has shading effect. Okay. Now this will lead us to discuss another type of modules. This type of modules is really helpful and really becoming a trend. Okay. This type of panels called the half-cut cell modules. So here you can see that we have the full cell monocrystalline, the full cell monocrystalline, and the half cell monocrystalline. Okay, so the crystalline here, as you can see, here we have our panel, and behind here we have the junction box that provides the positive and negative terminal of the PV panel. Okay, now this panel is a monocrystalline type, okay, which we have discussed before. Now, instead of having one cell like this, one complete cell like this, we are going to divide our cell into half. So we will have half cut cell. You can see instead of one cell, we will divide it into two parts, two halves. We will cut it. So we will have half cells. So we will have another panel which is formed of half of the cell. You can see half cell, okay, compared to this one which is one big cell. Okay, now why do we do this? What is the benefit of doing this? So here, and as an example, okay, this is an example to understand the benefit of having the half cut cells. Okay, so let's say we have here cells. This is a panel and this is another panel. This one is a monocrystalline type and this one is a half cut cell panel. Okay, now you can see that here in this panel we have 3 bypass diodes. Okay, so each bypass diode will take a string of cells. Okay, so this bypass diode is used to bypass this string, okay, a string of cells, and this bypass diode takes this part, the second 2 rows or 2 columns, and this one will take the second 2 columns, the third columns. Okay, so for example, if we have a shading effect here, for example on this panel, then this bypass diode will start working and bypasses this string. So in this case, what will happen? We will lose 1/3 of our power. Okay, we will lose 1/3 of our power. So we have here 60 cell and we will lose 1/3 of the power, because if we have a shading here, this bypass will work and cancel this string. Now what if we have a half cut cell? So a half cut cell here, and instead of 60 we will have 120, because we divided each cell into 2. Okay, so what will happen here? You will find that if you look at this figure compared to this one, instead of having 3 strings, you can see here 3 strings, this string and this one and this one, you will find that we will have 6 strings. We have 1, 2, 3, and since we are half cut, you will find that we have 4, 5, and 6. Okay, and our bypass diode will be installed here. Okay, instead of installed here. Okay, so if one of these strings have a problem or a shading effect, we will lose 1/3 of the power. However, in the second case, if for example we have a shading effect here only on this part, what will happen? This bypass diode will cancel this part only. So we will still have 5/6 of our panels. Okay, or to be more specific, we are losing 1/6 of our power. Okay, or 1/6 of our strings. You can see 1/3 of the power here, 1/6 of the power. Okay, due to the usage of the half cut cells. So you can see that in the first case of the 60 cells monocrystalline, we lost 1/3 of the power, since our panel is divided into 3 strings by the bypass diode. Remember, here's a string. What does this mean? A string of cells, not a string of panels. In the second case of the 120 half-cut cells, we lost only 1/3 of the power for each part, since we divided the panel into 6 strings. So what are the different advantages of using the half-cut cell? Number one, as you know that the power losses in any electric circuit is directly proportional to the square of the current multiplied by the resistance. As you know that the electrical losses equal to current square multiplied by resistance, or B equal to I square multiplied by R. Okay. Therefore, when cutting a solar cell in half, the power losses are reduced by a factor of 4 or by 75%. Now, why is this? Because if you look at this figure, we have the full size and we have the half cut size. So here when we divided our panel into, or our cell into half, then it means that we will have here I over 2, half of the current. And here we will have I over 2. So as you can see, we had here the total current I, then which is this figure, okay? So the original power losses I square R. In the half cut cell, we divide it into two parts, half I and another half I. Okay, so in the second case, power of each part is equal to I square multiplied by R. Okay, multiplied by resistance. Now the current itself is reduced by half, so it will be I over 2. Okay, since we have half of the cell. So it means that our power losses will be I square R divided by 4. Or it will be 0.25 of I square R. So what does this mean? It means that our power losses is reduced from 100% to 25%, or our power losses are reduced by a factor of 4, which is 1 over 4, or by 75%. Okay, and instead of having 100%, we reduced to 25%. Okay, and this came from I square R, as we said. Now, when the area of solar is cut in half, the amount of electrical current, as we said now, by each bus bar is reduced by half as well, as we said here. This decrease in the electrical resistance within the bus bars results in an over increase in efficiency, because as you can see here, instead of having this long bus bar, we now divide it into half, so the length is smaller, so the resistance is smaller. So this will lead to an actual increase in the efficiency per manufacturer, which varies in the range between 1.5 to 3% efficiency increase. Now, as you can see, half-cut cells here and the monocrystalline. Now, what is happening in the market? If you look at the market in 2017, you will find that we have full cell technology, one big cell like this one full cell, okay? And we have another technology, which is the half cell, which I just discussed, dividing it into two halves. And we have another technology which I didn't discuss, which is a quarter cell, which means 1, 2, and 3, and 4, dividing our cell into 4 parts. Okay. Now, as you can see, in 2017 or 2017, you will find that most of the panels in the market are full cell, very large full cell, and very small portion of the market is for the half cell, and the quarter cell does not exist. In 2018, you will find that the market share for the half cell just increased a little bit, okay? And as time passes, leading to 2018, we predict that it will be this part. You can see the quarter increased and the half-cut cell increased a lot because it is much better technology. So it is predicted that the market share for half cell will jump from 5% in 2018, you can see here 5%, to up to 40% in 2028. Okay, so in this lesson we discussed the shading effect in PV system, and we discussed how to solve this problem, and we also discussed the half-cut cell technology.